Hello students and welcome back to Mechanical Engineering Practice and Graphics. This week we're going to be covering the chapter 12 of the book, Assembly Modeling, the first part. So according to our schedule this week, we're going to have only this class, and very important, on Thursday we're going to have the second midterm. This is another, I guess, 20% of the final grade, so this is an important exam. And also, you will be submitting this weekend the third part towards your final project. Remember that each member is submitting their own individual parts for the group. Each of these parts must be different. Not only the 5 parts must be different for a member, but also within the group. So if a group has 5 members, there must be at least 25 different parts in the group. Um, Remember that um, each part must have at least 3 different features uh, to avoid simplicity, just be a little bit creative. And also, doing, for example, the right front door of a car is exactly the same as the left front door. It's just one is the mirror of the other one, so they are completely symmetric, and therefore this is only one part. Also, a wheel, for example, that you can use 4 times in a car, is only one part that is being used 4 different times. So with that in mind, all of you have to do at least 5 different parts for your projects, and the goal is to put all of these parts together in an assembly. Now, today's class is going to be about assemblies, how to put different components together. Um, you're going to be doing this in further homeworks, and also in the final exam, you will be doing an assembly. I'm going to provide the parts to you, and then you will be doing just assemblies. Also, next week, I'm pretty sure that the homework for next week is going to be just an assembly. So remember, we're in week number 11, marked by this arrow here. And then I'm going to provide all of these different components. You can see all the geometric information for these parts here in the slides. So this is one part, this is another part, a couple of different parts with some screws as well, and some more. And finally, this is an assembly. So in this blueprint, what we're watching is actually a top view of the whole assembly with a section view shown here, and also a section view BB showing here on the right. And then you will see that each component is marked by a balloon with a number. And then I have a list of parts for this assembly. So in this case, I have 10 different parts. Each part has their own number or name. If you want, you can also add a description for each part, and then the quantity. How many times do I need to use certain part in an assembly? This is pretty much or very similar to what you will find in an IKEA. When you buy anything in IKEA, you will find a list of parts. Each part has some sort of identification, and then how to put all of these parts together. So this is one representation. These are just the 3 standard views, usually used top, front, and right. Or you can replace certain of those views with section views that may add more information to what you're trying to show. Also, we do have this other representation. This is called a view in explosion. It means that some of the parts are just exploded out like in an explosion, so you can see clearer in a better way to represent where each screw goes or each different component goes in the assembly. So this tutorial today is not going to be graded. This is just a tutorial because we don't have any homework this week. However, I recommend you to try to follow the same steps. I will provide all of these parts in Blackboard because of what I've said. Future homeworks are going to be assemblies. In the final exam, you're going to be doing an assembly. And also in the final project, you need to put all the different parts together. So you should learn how to do these assemblies. With no further ado, let's open SolidWorks. And this time, instead of doing a part, I'm gonna go to the second module, which is the assembly module. Now in this assembly, uh, it is it is asking me which parts to open. So this is the Windows files or folders navigator. I can just select any of these ones. So I'm gonna go with the just with the body is the largest part. And then I'm just gonna click OK. So I think I have these parts represented with materials, and actually I'm gonna show you if I open that part, just the part, and for instance I change the material. If I have it this way, whenever I go to the assembly, it will be automatically modified. Or for example, if I change, mm, let me see, if I modify anything in this part, for example, let's make this hole smaller, like that, and then exit this sketch. Whenever I go to the assembly, it will be automatically updated. So I'm gonna undo that, and the same will be modified here. So this is useful whenever you are doing your assemblies and then you realize that you might need to modify a part. Uh, your best you will be modifying the parts directly in the part, and then you can see if they fit together in the assembly. So here I have the part, and that one has the file extension SLD SolidWorks part. And then if I save this assembly, I'm gonna save it in a different folder. As you will see, the file extension is SLD which is SolidWorks assembly. So I'm gonna save this one as class tutorial. Now, a good practice though is to have, let me bring the folder here, slides, week 11. A good practice is to have all the parts within the same folder as the assembly. Therefore, I can then just compress this folder either in a RAR file or a zip file. And then I can just email this RAR folder. So all the parts are gonna be within the same folder. Whenever the other person gets this email, they will have to uncompress the file, and they will have just a folder with all the parts and the assembly file within the same folder. Okay, so as you see in the assembly module, we have different tabs as in the part module. We have the assembly, we can also do some sketches here, and evaluate, you can measure different components here. So for example, if I want to measure this diameter, to make sure that that is the correct diameter, you can use this tool. Um, but the ones that you will be using most of the time are gonna be in the assembly tab. You will be using the insert components, the mate to add relations between different parts. Uh, you may want to do some patterns if that is the case. You may want to move parts. Also, whenever you're doing the exploded view, you will be using this control here. And then for the bill of materials, we will be using this control here. Okay, now what I'm gonna do is I'm gonna insert a second component. So as you see, the vice body is already in this list. I can bring a second uh, item for this part. Or the other thing that I can do is holding the control key in the keyboard, I can just click the part and move it, and that will create a copy of the same part. Or I can also do some patterns if that is the case. Okay. In this, for this assembly, I just wanted to show you that you can do copies of the same part. So I'm gonna just go ahead and delete them. Then if you click in this arrow, you will see like all the operations that were necessary to have certain part. You can also modify parts here, but it's not recommended. And well, yeah, SolidWorks will show you the warning. So we can do the same here. The problem with that is that you will be modifying all the other parts that are the same. Okay, now in this assembly we only need one, so I'm gonna just select these two, right click and then delete them. Sorry. And again, we have only this component. Okay, now I'm gonna insert a different part, and to do so, I will click here in the insert components. Then I'm gonna click in browse. I'm gonna look for the vice jaw, this part here. Now we can just click this one and try to move it around. I can also rotate it. Sorry, using the, I guess it's the shift. Now to rotate components, I will have to go into move component and then rotate component. And I can just try to orientate it. Now trying to put this part in that we're moving in 3 dimensions, trying to place it in the correct position is gonna be very difficult because we have only like 2 dimensions in the screen, but then these bodies are 3D. So trying to put the parts just by dragging and rotating them, it's very difficult. And therefore we have to use the mate option. So the mate allows us to add relation between surfaces, lines, points, not only from one single part, but also for different parts. So for example, I know that this cylinder and this other cylinder, they both are as we see here, they are concentric. So I can either click here or I can click here, and then I can accept here or accept here. And I'm gonna try to move this one around. So you see that whenever I try to move it, it is already recognizing that those two cylinders are concentric. And then I can only move it that way. The other thing that I can do here is between flat surfaces. So for example, I'm gonna select this flat surface and this other flat surface. And they both can be either coincident or parallel. But in my case, I know that these two surfaces are gonna be in contact most of the time. So making them coincident makes a lot of sense. Then I can just click OK. And see that whenever I try to move it, now it is keeping that both surfaces are actually the same surface. Like that. Okay. Now I can insert a new component here. I'm going to insert this time maybe the screw bar or the jaw screw. I think this is the one, jaw screw. Yeah, this is the correct one. So this one actually goes through this hole and through this hole. So once again, we're going to use the make component to add a relation between this cylinder and this hole. They both are concentric. So this one is going to be moving all the time. And then the other relation that we're going to do is that this face for this cylinder is going to be in contact with this face. Sorry, not that one. So what I'm going to do is I'm going to move this one to the outside. And then I'm going to click in the mate. I'm going to select this inner face and click this one. And then I'm going to select this other face. Those two faces are coincident, so this is okay. And then I can drag it back inside. Just like that. So that last relation, what it's going to ensure is that whenever I move this component, the bar is going to be moved as well. They will move together. Now, this happens only when we have a philister in here. So I'm going to input that philister now. This one, the oval philister. And again, we're going to add relations here between the cylindrical face of this philister and the hole where it slides. This cylinder here, and they both are concentric, just like that. And then okay. Finally, this face is always in contact with this other face. So we can just click OK there. And that's why I wanted to make this part like made out of glass, so you can see inside what the philister is doing. The philister is actually the one transmitting the force from this cylinder to this jaw. Okay, now let's input um, I think it is the screw bar. Yeah, this is the one. If you're not sure, you can always go back here and check the list of parts. So in this one, I selected the number six, which is the screw bar. And then the relation is using this face and the hole where it slides. They are concentric. And then I can just try to slide it there. Okay. Now I'm gonna insert the bar globe, two of these. So I can just make a copy holding the control key in my keyboard. That's it. And then adding a relation between this hole here and this face. I can switch the direction. This one is for undoing the last operation. And then I can click OK. The other relation here is between this face and this flat surface here. As you will see, those globes have different faces. So at this side, we only have this flat face, and in the other side, we have like some sort of decoration there. So I'm gonna do the same at the other side. Flat surface with this other flat surface. Then okay. And this is taking shape. Okay, now let's focus what is going on underneath it. So I'm gonna use the clamping plate. That one is this part. Now this part, here we have that this face, again using the mate control, is actually in contact to this other face. As you see, in this case, I need to flip the direction. So I can just click flip direction and then OK. And then this cylinder goes with this cylinder. And then this other cylinder, it's concentric to this other cylinder. So we have that now. Then I'm gonna insert um, the clamping plate. Sorry, actually the number 5, which is the base plate. I'm gonna insert a copy of that one. So now I know that this face goes with this other face, but in the other direction, just like that. And then we have that this cylinder goes with this one. And this other cylinder with this other one. Like that. And the same at the other side. Okay, this is a good moment to show you um, the list of, so here on the left we have the list of parts, and each part has all the different operations that you created during the creation of that single part. But also we have here the relations. So the first one was these two concentric, then these two coincident, and so on and so forth. These are the last ones that we used. So if in any case you need to delete any of these relations, you can just deploy this menu here and right click on the uh, relation that you want to delete, and then you just click here in delete. Then you will be able to move things around again. All right, now I need to add the screws. Um, so here we have two sets of screws. This is the first one, and then I'm gonna add also the second one. So these ones that are longer are going in here. So mate, and then I select this face with this face, and then I can, but maybe I should just go, I should do a copy first and then create that relation like that. And then I should use also four of these. The first one goes in this face. The second one goes in this one. Then this one goes here. And this one goes here. And that's our assembly finished. So we have 10 different parts, and all of them are just a single assembly. Now, if you save this as an assembly, uh, I can close this and then open it again if I need to modify it. And since I have the assembly and all the parts in the same place, I can continue editing this assembly. But if for whatever reason I move any of the files to a different location, then the assembly will not work. So that's why it is important of having everything in the same folder. Now the bill of materials, I will show you, you just have to click here, bill of materials. You can show only the parts or top level only. So there are a different sets of controls here. I'm gonna create a new annotation view, and then we can have this list here. This one is gonna be useful if you are trying to have control of how many parts do you have, how many of each single part have you used. Also in the description, I am including the material of some of these parts. So I have cast iron, alloy steel, stainless steel, steel, mild steel for different parts. Also, so what you can do here is also do the exploded view. And if you're gonna do the exploded view, uh, just be careful. You will have to do it correctly in order, like everything must be correct in order to save this. So for example, here you will have to select the part, each individual part. So I'm gonna start with the oval philister, and then I'm gonna displace this one let's say 70 millimeters. Done. Then this part also in the Y direction. Let's make this one 40. Then done. Then I'm gonna select this one, but you can also select several components at the same time. As you see, this list here on the left is growing whenever I click more and more components. And then I can select the Y arrow to display them below. Let's make this one 120. Now I can select this one, this one, this one, and this one. I'm gonna move them in the X direction, something like that. Probably 110. I'm done. Maybe I should also displace these two in the Y direction, something like that. And finally, this other one, maybe also down. And then I can just click OK here. So there I have my exploded view. And whenever I do the blueprint of this assembly, I will have access to that assembly view, to that exploded view, sorry. Here you can also do what is called the exploded lines. So in this case, you can either do one by one, or you can use the smart control. So in this case, I'm gonna add the smart control, and it will create lines from uh, the final position for each component, from the starting position, and then I can just click OK, and then we will have these lines that are showing like, okay, so all of this should move here to the left. This philister should move downwards. All of these components should move upwards into the vice body. And that is pretty easy from the smart control here. Insert edit smart exploded lines. Or you can do each one by one with this control as well. I'd rather do everything automatic. I think it's faster. But if you want, you can just select component by component and then draw the line. Sorry. You will have to select two components actually. This one actually goes, sorry. You will have to select like the faces that are connected. Like in the oil philister, you can select the cylinder and then the hole where it goes. And then you will create that line. So as you see, it's kind of too much trouble. I just prefer doing it the automatic way. And that's it for this tutorial. So remember that, uh, okay, so, well, one thing before we finish is you already learned how to save this as an assembly, and then whenever you're doing assembly, then just take a screenshot, just as the usual, what we do with parts. You will take a screenshot or several screenshots of your progress and upload a PDF. Um, Remember that for this week, we will have the second midterm on Thursday, that you don't have any homework this week, that you have to submit the third part for your project. So you must have by now half of your final project done, I will say. Uh, I would recommend now that you learn how to do assemblies to start putting all of this together. Maybe just create a share folder either using Dropbox or or the service that we have in OneDrive from the university. Um, just create a share folder or even in Google Drives and start putting everything together. That's a suggestion for the final project. Thank you very much for watching this video. See you on Thursday for the exam and next week for the class.